What we are primarily going to focus on today is, again, the machine design in SolidWorks, and maybe a couple techniques that might make things a little bit easier for you while you are going through that machine design process. Some of the key things that we are going to take a look at is the use of smart features and smart components, and just the intelligence that they bring to your models. That way you can reuse the same designs over and over and over again without having to recreate and redo all of that stuff that you've been working on, like grooves and rings and features and just things like that. And you're going to see a lot of that during this demonstration. What we're also going to take a look at is 3D Content Central. So if you haven't used 3D Content Central or haven't heard of it or aren't familiar with it or anything like that, we're definitely going to take a look at that to see what benefits we can achieve by utilizing 3D Content Central. So what I am going to start with is my assembly design here, and even more importantly, the e-drawing for this assembly design. And this is just to give us an idea of what the assembly is missing so far. Now, what we're working on here actually, and I could even open up the main assembly if we wanted to see this guy all finished, but we'll save that for later. What we're working on is a machine that basically puts like caps on bottles and things like that. And it's going to have this rotary sort of machine in the middle of it that spins the whole machine, makes it all turn, makes everything work. And you see here that we basically have a couple things inside of our e-drawing. And again, if you guys haven't ever used e-drawings before, this is definitely a tool that you want to start taking a look at pretty seriously. What it will allow us to do is share information about the model with people that may not have SolidWorks. They can add markups, they can do measurements and things like that, all right inside the e-drawing without ever having opened a SolidWorks model. So we'll see right here that in our assembly drawing up to this point, we have down here a grand total of 61 components at the top level of our assembly. And we'll see that we have a boss here that's added a couple notes to our drawing. Namely saying that the assembly looks good so far, but it needs to add a motor and a gearbox. So there's actually no motor or gearbox down here at the bottom to actually make this thing work. Also, we'll see that it says, add a drive to the rotary cam. Basically, this should be at an 18:1 ratio from the main drive shaft. And what it's basically saying there is that we're looking for a couple belts and cams and things like that to get in there, basically just to make everything work off the motor. So we still have some work to do on the assembly, but what's just really nice about showing you the e-drawing first is that we have the ability to, share this information with a manager or, with purchasing or with anybody in the company that does not necessarily have access to SolidWorks. It's a free download, and you can actually send the installation files with the e-drawing. So if they don't have e-drawings, you can have them just unzip the file, install it, and open up the drawing right there on the fly. So it's really easy to use. So that said, I'm going to go ahead and jump into the drawing here. So we're going into the SolidWorks environment. And again, you can see that pretty much the entire thing all looks the same. We've got some balloon callouts here pointing out all the different parts and things like that we have inside the bill of material. But again, we know that a lot of these components are missing. So it's our job to come in and just add the rest of this stuff. Now, switching over to the assembly. We can get a better look at the model here, and we can kind of see that the majority of the stuff that we're working on is actually underneath the table in this assembly. And what we're going to take a look at first here is just display states. And again, if you guys don't use display states, it's something to take a look at. If I just right-click right here, we can go to our, our belt drive design, and you can see that what display states will do is allow us to change the way the assembly looks to focus on specific areas of the model. So we can see that if we were maybe working on the belts here, we might use this style of display state. And then also, if I switch over to my motor and gearbox, it gets rid of all the belts and the brackets and everything like that would be unnecessary while we're working on this assembly. So what we do need to do is drop in a gearbox and a motor right down here at the bottom of our assembly. Now, like I was saying earlier, the best way to do this, or the absolute easiest way to do this, honestly, so you're not reinventing the wheel and you're going through, a million times more work than you need to, you might want to check out 3D Content Central. That's what I'm going to do here, and that's actually found right in the design library. And if we click on 3D Content Central, I'm just going to jump into my supplier content, and let's just say all suppliers. Oh, I went to the wrong link there. Hold tight. So we'll go all categories and then go right there. So what this is going to do is open up 3D Content Central for me. I'll just click on the home right here, and we can take a look and see what 3D Content Central has to offer for us. Notice up here at the top, number one, is we have the ability to log in or register. So if you or your company want to log into 3D Content Central to utilize and download and access all these thousands upon thousands of files, you can go ahead and do that right here. The other nice thing about 3D Content Central is that all the companies that have already accessed and upload files for their company, they're all basically company certified parts. All the dimensions are correct, all of the information about the document is correct. It's pretty much ready to just drop into an assembly and use. And what we're looking for is a gearbox, and we can actually do this by specific features, we can do it by specific parts, or we can look for a specific vendor or supplier. So I'm going to go ahead and click on View All Suppliers here because this list is crazy. Look at all the people and the different types of companies and the different brands that are all using 3D Content Central. And what we're actually looking for here is our Peerless and Wingsmith. If you click on that, excuse me, what it's going to do is just give us a couple options for different types of gearboxes that they produce or that they would upload for you. And I'm going to go ahead and click on this guy right here. And based on that, they have a couple different versions of that gearbox. Diving in there, again, it gives us a couple more options of that type of gearbox. And what I'm going to do is select this guy. Oh, did I hear somebody saying something? Oh, maybe I was mistaken. All right. So what I'm going to do is just go ahead and grab one of these, and this is actually the guy that we're going to be using inside of our assembly. And what's really nice about 3D Content Central is that before you ever even before you ever even download the file, it's going to give us the ability to take a preview of this document in three-dimensional space. So I can actually rotate this guy around and just kind of debate whether or not this is actually going to fit into my assembly or how we want this to work. So this guy actually works out really nicely for me. And then right here you'll notice that it says that we have to log in, and I'm just logged in as a guest right now, so we're not going to be able to go through this. But if you click Configure and Download, it's going to ask you a bunch of information like what size do you want the gearbox to be, what file type do you want the gearbox to be. And then once you have all of that set, you can just download the document and use it right inside of SOLIDWORKS. Now, I have actually downloaded this guy already, and we're going to take a look at that inside of SOLIDWORKS. So I'm going to jump back into my assembly here. And we're going to see that right here, here's my Wingsmith gearbox. If I just drag that and drop it out into the assembly, you see here that it's just going to allow me to just drag it around and place it wherever I want. Now with the automate functionality, you notice that if I hover my mouse over the location that it's actually supposed to go, it automatically snaps into place and generates a mate that holds it there. So notice now I can spin it on that axis, but I can't move it around other than that location. So it just makes it a little bit easier for me to go in and grab some of this information without having to build the entire gearbox and waste who knows how much time with that assembly. Well, one last thing I'm going to do right here is just create a mate between these two components right here and just kind of line it up, make them parallel, and lock this guy into place. So now it's just kind of sitting out there and able to kind of do its job. Now, what we'll also notice with this is that the gearbox is just kind of hanging out there in space. It's not being held into place by anything, and that's obviously an issue in the real world. So what we're going to do is just throw in a couple weldments to hold everything into place. So I'm going to go ahead and just add it to the base plate that we have right here. So we're just going to make a couple modifications to this part to kind of enhance the way it looks here. So I'm going to grab a sketch and flip over to my top view here because we're actually going to inference the gearbox. So I'm going to go ahead and grab a sketch tool, and we'll just draw in a couple lines for our weldment profiles. There we go. And what's really nice about the weldment tools in SolidWorks is that that's really all you need to do if you're trying to create weldments. Because watch this. I'm going to go ahead and jump over to my weldment tools, click on structural member, and again, we have all these different styles and standards. I have ANSI inch. I actually have a couple of plates in there that we can drop in. And I'm going to go ahead and use ISO. For our type, we have angle iron, C-channels, pipes, rectangular tubes. You can also expand on all of these by simply creating the type of sketch that you want to use and just dropping it into your structural member library. Then we'll go ahead and pick our size. And lastly, define what we're going to be or where we're going to be placing those. So I'm going to go ahead and click right there. And what you'll notice is that after we drop that beam in there, we're actually intersecting our model a little bit. And we obviously don't want that to happen. So what I'm going to do is just change our location profile right here. Go ahead and click on that and just say that we want to locate that sketch line at the top of the profile instead of the middle. And you see that it automatically updates everything. So we'll just pick that sketch line right there, hit the green check, and now we have our two beams in there. Now let me ask you, I guess I'll take a break here for a second since we're at about a half hour, and see if you guys have any questions, comments, concerns, anything like that. I'm just going to go ahead and jump in here, see if there's anything in the chat window. It doesn't look like it. Again, feel free to unmute yourself, ask any questions you'd like. I'll just wait a couple seconds here before we get started again, and then we'll jump right back into it.
You're good, Johnny.
I think you're good. All right, good. I haven't skipped out or anything like that so far. Everything's been pretty smooth.
Audio's been crisp and no delay in the sharing.
Okay, excellent, good. Like to hear that. All right. So now that we have the two beams in here, obviously the two beams are floating out in space just as much as our gearbox. So we need to bring everything together. We need to start tying it all together. And the way we're going to do that is with our trim or extend tool in the weldment profiles. A lot of people know that this does the trim, but not too many people go through that extend option as much. And what I'm going to do here is just pick the two profiles that I want to extend and pick the boundaries that I want to extend them out to. And what you'll notice is that as soon as I click on those two bodies, both of my profiles extend in both directions until they touch. So I'm going to go ahead and hit the green check on there. And one last thing I'm going to do here is just change the transparency of the assembly, the file really quick. And what you're going to notice is that it actually cuts and forms these beams to kind of match the profiles that we already have in place there. So it's automatically taking all of the cutting and the trimming and everything that you would need to do manually, and it's taking care of that for us automatically, which is always really nice. Just the least amount of work we have to do, the better. Now, we have our beams in place, and what we need to do is get this gearbox to sit on top of them, because obviously there's a little gap right there. And the way to do that is with some sort of plate. Now, this is where we start to take a look at smart features. If you guys haven't used smart features, you actually have to do a little work up front. And we're not really going to take a look at that right now for time constraints. But again, we are going to take a look at how a smart feature works. And the way it works is this. Basically what we do is when we save out a file, when we attach a file to anything, we're bringing features and tools along with it. For example, before we brought this guy in, it actually comes with smart features. Notice it says insert smart features right there on that right click menu. If I click that, what it's going to do is bring my little pop-up open right here. And it's going to say, all right, well, we're going to bring in a bunch of holes and our extruded plate. So there's going to be a couple holes in there, for the plate and for the gearbox that we're sitting it on. It's going to come with an extruded feature, and then also it's coming with 4 socket head cap screws. So we've got different parts and different features all associated with this model that haven't come in yet. And if I pick the face that I want to plant it on, like our frame right there, and then hit the green check, notice that what it does is it drops in not only the plate, but also it's going to drop in those smart fasteners right there. And if I isolate our frame, you see that it also drops those four holes in there as well. So it's automatically bringing in all of this intelligence, and it's bringing in all these features. That way, if every time you bring in the gearbox, you're going to use the same plate, you don't have to keep building it over and over and over again. You just attach it to the gearbox, and every time you drop the gearbox in, it's going to bring all of that stuff with it. So let me go ahead and exit out of my isolate there. So there we have it, our gearbox sitting right there on the frame, and it's also attached to the rest of the assembly to give us some of that motion. Now what we also have to do is drop a motor onto this gearbox to make everything move. So what I'm going to do is, again, come over here to my design library, and this is just another component that we pulled off 3D Content Central, but here's my motor right here, and all I have to do is, again, just click and drag it out onto the assembly, drop it on. It's automatically going to build that mate, so notice now I can't even click or move it or anything. It's locked onto the gearbox. And if we flip this around to the other side, you're going to notice that, again, what we would need to do is attach all of those fasteners to hold this into place. Again, best opportunity to use smart fasteners or smart features. We just right-click on the component, hit Insert Smart Features, and notice right here it's just going to bring in all of our socket head cap screws. And in my preview, it's showing me that in the assembly, basically they just have socket head cap screws sticking out of the model. So I'm going to hit the green check on there. And you see that it automatically drops all of my fasteners into the proper location to hold everything into place. So that's basically how our smart features work there. It's going to make everything really, really easy to use. And you're going to see that a whole lot more as we're running through this example and through this demonstration, because it's going to make all of your machine design so much easier. And again, if you'd like, you can even type into the chat or something like that if you'd be interested in learning how to create a smart feature. And maybe that's something that we can touch on, at another time or at a later time on, building up the smart features and, importing them into a part and how we can store all of that together and everything like that. But after we have that assembly is pretty much finished, at least this section of the assembly. Then what we would want to do is move up to our pulley system up here. So we need to make sure that the pulley is set and ready to go. So what I'm going to do is change my display style here. I'm going to go to my belt drive design. And you notice that, again, by changing the display states, what it's doing is it's showing me a couple different components out here, and it's kind of turning transparent all the other components that, we may not necessarily need. Now what we can also do, just to show you how easy it is to change and work with design or with display states, if I were to right-click on any of these components and just hit hide, what it's going to do is for that display state, just always hide that. So if I were to jump back and forth between a couple, so if I go all components, notice everything comes back. And if I switch back to the belt drive design, you're going to notice that even though it was transparent before, now that base is completely hidden. So it just gives us the ability to hide and show different things, get down in the guts of the assembly so we can focus in on what we're supposed to be working on and not be distracted by all the other junk that's kind of going on around us. So what we need to take a look at here is basically how we are going to kind of put all these belts and pulleys together. You notice that we have a couple pulleys right here. There's actually missing something right over here. And what we need to do is kind of put together and manipulate this this bracket a little bit, get all the proper equipment on there to turn it into a pulley so we can finish our assembly. So what I'm going to do is actually isolate this portion of the model. So I'm going to go ahead and just window select that whole section right there. Hit isolate, and we're going to focus on just this area of the assembly because we have a couple key problems here. Number one, if you notice, none of the brackets or anything like that that we need are on this side of the assembly. We do have everything up here. If you notice, we have like retaining rings, and we got some bores and things like that, and nothing's going on down here at the bottom. So we need to finish up this assembly because it doesn't look done. Also, what we're going to notice is that this bracket's actually a little long for this shaft, so they don't quite meet each other there, and we need to make a couple modifications to that. Now the first thing that I'm going to do here is change that bracket. So we do want to shrink that bracket up a little bit, but before we even do that, let's take a look at the components that we have to insert here. I'm just going to do a quick section view of my assembly. Pull it into view here, and this is probably a pretty good location to do it. And if we zoom in up here, you're going to notice that we have a couple different things going on. We have this bracket right here, or we have a bearing, and you notice that it's basically got a 17 millimeter bore in it. All right, so we're just keeping track, keeping in our minds 17 millimeter bore on that bearing right there. What we also have up here is our retaining ring, and if we take a look at the retaining ring right there, we see that that's got a 40 millimeter bore on it. So we have a couple dimensions that we need to keep in mind because the same thing's pretty much all going to be happening down there at the bottom. We see that it's got a couple cutouts in there to kind of like take into consideration the sizes and shapes of everything that's going on. So again, we're going to probably need to do a little work down at the bottom to make sure everything fits properly. So again, first thing I was going to do is drop this bracket a little bit. And the way we're going to do that is to just edit the sketch on this guy. I'll see here that right now, basically the way that it's being driven is by an overall height and thicknesses throughout. And what I actually want to do is just change the way that this height is driven, and we're going to say that we want the bottom of the model to be offset from the bottom of the sketch a certain dimension. But you notice here that by doing this, we are going to over-define the model. So you're going to see that this 25 basically says, well, you're telling SOLIDWORKS to do the same thing a couple times. We need to fix that. And if you haven't ever done so already, by clicking on the Over-Define button down at the bottom of the screen, it's going to bring up your Sketch Expert, which will give you a couple options on how to fix the problem. So all you have to do is click Diagnose, and it's going to give you a couple options on how you can fix the problem. And if you notice, our first resolution of the problem is to delete the dimension that we just added there. Now obviously, because we want the dimension to be there, we may not want to delete it. So if I take a look at the second option, it's saying, well, okay, we can have the 25, but you have to get rid of this 200 over here. If you like the way it looks, if you're happy with the result, you click Accept. And notice now it says the sketch can now be finally validated properly. So if I hit the green check on there, we can now just double-click on this dimension and change that maybe to like 5 millimeters. You see that we pretty much have the same gap on both sides now. And the bracket's about the size that we're looking for. So I can go ahead and just click Exit Sketch, and you see that everything's updated. Everything looks a little bit better. Now, after we've done that, we need to do a couple more things. We need to throw our bearings in there. We need to throw the retaining ring in there. And the way we're going to do that is with the design library. And again, if you guys aren't using the design library, that's where I was just pulling all of my, like the motor and the gearbox out of. And what it is basically a library of all these standard components that you continuously use over and over and over again. So right here, you see that we actually have a bearing saved in there. And if I pull this bearing out, what's really, really neat about this is if I drop it onto a cylinder, you're going to notice